Hi guys, how are you? Welcome back to our channel. I am Avni, your tutor for the logical reasoning section, and we discussed in a previous videos about alphabets and alphabetical patterns and different ways to approach it. In this video and the next 2 to 3 videos, we are going to be talking about number problems in logical reasoning, and I'm going to be starting with telling you a few patterns, a few rules that you should follow to be solving all of these number problems in bank PO exams. But let's just not do that. Let's take a different approach this time. Rather than telling you, just like in our alphabet problems, I told you that there has to be a chart, things that you should remember. Let's try it a different manner, a non-Indian manner that I call. Let's try and approach the problems first. Let's try to identify what all things do we need to learn, and then we'll summarize it, and then we'll talk about patterns. This will also help you, challenge your brain and maybe your skills that you learned in school, and well, it's going to be fun. So let's get started. Hello class. So in this episode we are going to be talking about the number problems related to logical reasoning. Numbers can be a little tricky, in fact a lot tricky. There are a lot of concepts that you need to know before you start solving numbers. It's not just logic, but it's also a lot of number memory. So I'm going to straight away start with a question, and then we're going to see what are those logics and what are those numbers and relative information that you need to know in order to solve these problems. So we are going to summarize it all later on, but for now we're just going to straight away start solving the questions. So shall we start? The first question from a previous year paper is: four of the following are alike in a certain way and so form a group. Which is the one that does not belong to that group? So it's again an odd one out problem that we have been solving in our previous videos or episodes for alphabet. We're going to do the same for the numbers, but in a different way. So let me write down the options here. 168, 728, 290, 380 and 120. Now look at these numbers like really carefully, and you can take all the time you want, but try to identify a few patterns. I would suggest pause the video, because I'm anyway going to continue. I'm sorry about this. I'm anyway going to continue giving an answer to all of these to this question. So it's better just pause the video, look at the options for 2 minutes, and then watch the rest of the video. So in this particular problem, as many of the problems related to logical reasoning and numbers would come, such problems are usually related to the squares or cubes or divisibility rules of the numbers. So most of these problems are concerned with squares, cubes, divisibility rules. Let's have a look at this problem. So clearly none of the options is a square or a cube. Let's go with 168. Look at this particular number carefully. Does it remind you of any square root? Let's say, for me, it's acting as a hint to 169. I mean, sure, it's not 169, but it's really close to it. Or we could say that it is 168 plus 1 equals square of 13, which is 169. So somewhere we are able to establish this pattern, because we know that 13 square is 169. Whenever you solve these problems, you need to identify these kinds of squares or cubes in all of these options. So because you know that 13 square is 169, it gets a little easier. So because I remember it, it was easy for me. This is what we are going to be talking about at the end of this episode also. Then there's 728. Now this particular number is, so 728 minus 1 equals to 7. 729 minus 1 equals to 728. The same was this. I mean, if I had to write this in a different manner, I would have written 169 minus 1 is equal to 168. So we found a pattern. We found a pattern that square root of some number minus 1 equals to one of these options. But as I have always told you, always first look at 3 numbers, because 3 options, because it's very important. So we'll go with 290. Now 290 also reminds us of one square root, which is 289, but it is in the reverse order. In this particular question, we were doing 169 minus 1. Here we'll be doing 289 plus 1, which is equal to 290. It's very tricky. It's one sign difference, plus and minus, and that's it. So this number does not follow the pattern followed by these two numbers. Now we'll go with 380 and 120 and check for them. So whenever you look at the number 380, you are reminded of 381, right, which is 19 square. So this would be 381 minus 1, which is 380, which again follows the pattern. And then there's 120. 11 square equals to 121. 121 minus 1 equals to 120. This also follows the same pattern. Now that you've established that 4 of these options follow this pattern and this doesn't, it's very easy to conclude that this is the odd one out. Although when you have to go through this path, because I told you it was easy for you, but in those 2 minutes you must have been thinking a lot of things. That maybe I would multiply this with something 13 plus 2, 13 into 2 or any other number, plus 5 plus 6 plus 7. So when you are very familiar with these squares, these cubes, or the divisibility rules and other stuff as well that we might be discussing later, you are able to very easily connect with these options. So this is something that we really need to understand. It's always better to approach the problem first and then summarize, which is what we are doing in these videos, but we have established this. So the first thing that we need to know about logical reasoning in numbers is that you always need to know the squares and the cubes of the numbers. This is how we are going to be solving these questions. In our next episode, we are going to be discussing even more tricky problems with different approaches. So, well, let's check out in our next video. In fact, let's do it in the same video. Let's start with another question related to logical reasoning of numbers so that we have more variety to talk about in the later episode. So now the next question is, 4 of the following 5 are alike in a certain way and so form a group. Which is the one that does not belong to that group? Again, the odd one out, and I'll write down the options. 131, 133, 143, 87, 5 and 57. Again, pause the video for 2 minutes. Just look at these numbers and find an approach that works for you. If you want to pause it for 5 minutes, do that. Use your brains. Anyway, we are going to come to the answer. 131, 133, 143, 87, 57. In all of these numbers, we can first check for squares and cubes and all kinds of things, because that is the approach we'll take, because the last question that we solved was related to squares and cubes. But it's very clear to me when I look at this that this could be a divisibility problem. For example, 57 here, it's like divisible by 3. 87 here is divisible by 3. How did I check that? Well, according to the divisibility rule of 3, whenever you have to check whether a number is divisible by 3, you add the digits in the particular number and then you check whether that is divisible by 3. For example, it's 5 and 7. So 5 plus 7 equals to 12. 3 into 4 equals to 12. So we know that this number is divisible by 3. And so obviously this is not a prime number. Then you come, obviously we know what a prime number is. A prime number is a number which has only 2 factors, which is 1 and the number itself. There are no other factors with which we can multiply it. So 87, again 8 plus 7 equals to 15. 15 is divisible by 3. So that also is not a prime number. Then we come to 143. So as far as I remember, it is a multiple of 11. But if we have to check this, if we have to put a divisibility rule around this, then how do we go about it? So for 11, we have got this particular rule that It's a very common one. There are many rules to check for divisibility for 11, but we'll go with this one, that the sum of the even digits minus the odd digit should be 0. So let's do that. These are the odd digits. 1 plus 3 equals to 4. This is the even digit. Minus 4 equals to 0. We know if this holds true, this particular number is divisible by 11. Which means this also is not a prime number. Why did I check the divisibility by 11? Because somewhere in the back of my head I knew that I've seen this number around. Or maybe if you want to go by the whole procedure in the beginning if you want to do that, you can do that. You can check for 2, this is not an even number, so obviously it's not divisible by 2. Then you go check for 3, then you go check for 4 according to their divisibility rules. But as I've always said, this particular section, this logic, I'm sorry for rubbing it out, but this logical reasoning section, it will be more based on practice and the patterns that you can identify. It will somewhere be at the back of your head and your insights will develop accordingly. So even with numbers, when you solve a lot of problems related to numbers, this part will become more clear to you. Then we come to 133. Now for this number, I have somewhere in the back of my head that this number is divisible by 7. For 7, I think we should talk about a divisibility rule in a much detailed manner. Although we could cover a different episode on that, but for this one, so like a simple way would be to test for the nearest number that you think is divisible by it. So let's say 140. We know 140 is divisible by 7, right? 7 into 20 equals to 140. If this is divisible by 7, then 140 minus 7 should also be divisible by 7, which is 133. So we found out that this number is also not prime, which is not actually leading us anywhere because we experimented with 4 options and all of them were non-prime. So probably this is not the right approach, but let's check for 131. We're going to be talking about these divisibility rules in detail and even about the squares and perfect squares and cubes and everything else. It's just that these are the hacks. These are very little hacks. Like for 11 you could have a different kind of a divisibility rule, but let's stick with this. Even places, odd places, subtract, and you know if it's 0, it's an 11. For 7, we didn't actually talk of any divisibility rule. We just talked about how you could roughly estimate it. 140 minus 7. If this number was, let's say, anything else, I mean, if this number was 135, obviously we know that 5 is, if there's a 5, it is a multiple of 5. But even if you wanted to check it in this particular manner, you would have checked 140 is also divisible by 5 or something of that sort. Something which makes you reach the particular option or the particular conclusion in a quicker manner. So whatever works. And then there's 131. Now, to declare that that number is prime, you'll have to run a few tests, which includes all kinds of divisibility rules that you'll test it with. Now, this brings us to our last option, the first option. So now we have to test. We have declared, we have concluded that this, and this, they are all non-prime numbers. Now let's run a test for prime numbers on this particular number. So how do you tell whether a number is prime or not? You tell whether a number is prime or not by first identifying the nearest square for this number. For 131 we have 144, right, which is 12 square. Now what you do is, because it's 12 square, you list down all the prime numbers less than 12, which will be, I'll write them down here, 2, 3, 5, 7 and 11. So you've got all these prime numbers. Now you will test their divisibility with these prime numbers. It's definitely not divisible by 11 because we just tested that 143 is divisible by 11, you subtract, it's not. Then you go and test for 7, whether it's divisible by 7 or not. We just saw that 133 is I'm just telling you the hacks. Obviously you can do it by proper divisibility rules that we are anyway going to be discussing, but these are pretty simple hacks. If you're just looking at it, 133 is divisible by 7, then 133 minus 2, 131 can definitely not be divisible by 7. Then you've got 5, obviously not 0, not 5, so this is not divisible by 5. Then you've got 3. For 3 I've got this rule, right? You add all the digits and then you see whether, so 3 plus 1 is 4 plus 1 is 5, and 5 is not divisible by 3. So nope, 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 nope. Then you test for 2. It's not an even number, it's an odd number. So now you have tested it for all the prime numbers less than 12, which leads us with this conclusion that this particular number is a prime number. This question was actually very easily solvable when you knew the right approach. Although we can never always be sure what is the right approach. But yeah, I mean, as you keep solving, it will become more clear. And now we talked about two different scenarios, right? In one, there was square numbers, plus minus the square of a number, and we talked about prime and non-prime numbers. In our next question, let's try to cover a different kind of a variety. So we've got another odd one out question, just like the rest of them. I mean, the question text reads the same, so I did not read it out. I've written all the options here, and honestly I'm feeling a lot more confident because I actually began solving these questions with you guys only, and now that I've solved 2, it is actually making sense to be solving this third one, which is the 15th one in the logical reasoning series. But okay, so do the same again, just pause the video, look at it for 2 minutes, and then try to identify. Here, when I look at this, it's somewhere making sense with the numbers that we are familiar with, like 126 is somewhere close to 125, making sense. And we know that 125 is 5 cube. So yeah, it's ticking, it's somewhere ticking. There's 730, which is closer to 729. Then there's other numbers that are close to some numbers that we have seen and observed that somewhere are squares, or maybe if not squares, but they're more familiar. So as you grow up, solving all of these math problems, somewhere there are a few numbers that stick in your head, just like 125. You will somewhere look at it and you're able to tell that this could be the square or cube of some number. Obviously, if you learn it by heart, it's obviously going to be the best way to do it, because we're going to do that anyway. We're going to write a list down and we're going to try to remember as much as possible. But these numbers, they click. They somewhere at the back of your head make sense. So let's start with that. Let's say 125. Okay. So 125 is 5 cube. I already wrote that, so I won't repeat it. It's 5 cube, and it's, yeah, so it's making sense, and it's also 25 into 5. So somewhere, so you just put it down, but it's 25 into 5, but let's just consider it 5 cube, 5 square into 5, whatever. So let's just consider it as 5 cube, because as I said, all of these squares and cube related problems will create patterns in these logical reasoning numbers. So it is, if you go and look and solve for this formula, it will be somewhere 5 cube plus 1 equals to this option. And let's consider this as n. Somewhere this pattern, this formula that we were supposed to be writing out in alphabets, also we did this. So we have established one pattern, n cube plus 1 equals to x, let's say, which is the option. So we want this to be equal to this. So first number, we identified that. Let's go and look at the second option. It is 270. Now let's try and match this with this formula. In our previous questions, we didn't do that. We did it all randomly, right? Let's try and solve this way. So n cube plus 1 equals to x. Here our x is 217. So n cube plus 1 equals to 217. N cube equals to 217 minus 1, which is equal to 216. And we all know what this n cube is going to be. It is going to be 6. There are various ways to identify this also, which we will discuss in detail later, but this is a very common number, a very apparent digit, 216, it's cube of 6. So it makes sense. If n is identifiable, then it makes sense. If you can solve this problem this way, and there exists an n for which this particular formula holds true, then you've got it right. In fact, you don't have to write a formula. It's just one method that I'm suggesting in case you falter, in case you're not able to tell where to go, what to do. writing it down in the form of a formula always helps. So this is true, this holds true for n cube plus 1, this holds true for n cube plus 1. Let's go and have a look at this option. 345. Okay, so 345, we'll solve it the same way. So let's do it here. Let's n cube equals to 345 minus 1. If you go and solve this, so there's this number, okay, that I can see. It's 343. I don't even have to tell it. I don't even have to test it. It's 7 cube, 343. These are the patterns that should be there in your head. So there's 343 already in my head. 343 and 344. Obviously, I mean, 343 plus 2 is 345. Okay, and 343 is an n cube. It is a 7 cube. So these were following the patterns of plus 1, and there would be plus 1. Let me change the marker. N cube plus 1, and now we've got 345, which is n cube plus 2. You're able to establish that pattern, right? This could be n cube equals to 344 is not true, because 344 is not a perfect cube of any number. So we have kind of sorted. This holds true, this holds true, this does not hold true. We have 3 options and 1 pattern that holds true for 2 and not for 1. Let's test it for the rest. 513, close to 512, which is again 8 cube. 8 cube plus 1, plus 1, plus 1, plus 1, this is right. 730, 729 is the nearest cube, which is 9 cube. 9 cube plus 1 is 730, which means this also holds true. This brings us to the conclusion that all of these numbers hold true for this particular formula, in which you say n cube plus 1 equals to this particular number. But for this, there's n cube plus 2. Now, it's very common that you make a mistake with this, because somewhere in your addition, in your so there's one plus point of knowing the patterns and one minus point. If you know the patterns very well, it's very easy to get mistaken. Why? You're somewhere trying to reach that pattern. It's somewhere in the back of your head, it's somewhere in your subconscious. You're trying to reach to that pattern, and you tend to ignore a few calculations. So please be aware of that. Like, do not ignore any kind of calculation. Be very, very particular. Plus 1, plus 2, plus 1 mistakes are very common. You can easily make them. Like, rather than 1, you consider 2, and then it's good to go. No, you have to be very careful. And I'm not trying to intimidate you or anything. It's just the way these problems are solved. One important thing, again, as I always say, reaching the right answer is much more important than solving it quickly. Because once you are solving the right way, you'll anyway start solving them quickly. So remember that, and keep track for all of these mistakes that I discussed. And let's wrap this up, and in the next episode, let's solve more of these problems. I hope you enjoyed this class, and I hope you liked the kind of questions we solved. We covered cube numbers, we covered squared numbers, we covered prime and non-prime numbers. We solved 3 important questions and patterns that are asked in Bank PO exams. But let's explore more in our next episodes, and I hope you are practicing. I keep telling you, practice, 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 because it won't get better unless you practice. So keep practicing, keep watching our videos, and keep rocking.